to review, and then we'll also review on Monday. I do give tests on Mondays, but I just thought maybe having an extra day to review on Monday and giving the test on Tuesday. But that means then when we go to take the whole chapter test, there'll just be one day to review. I think the first half of this chapter is a little more involved than the second half of the chapter, because the second half kind of uses most of the stuff that we've done already in the first half. And the first half has a lot of new stuff in it. So looking at number 39, I like this problem because it has a square root in it. And it's not just a number like -3 or a fraction like 1/2, but it's working with the square root. So like these are the problems that I would assign for honors trig and pre-calc. When I taught regular trig and pre-calc, I could have probably skipped this problem and would have assigned them just the ones that had fractions or integers. So it's kind of like a difference in the style of homework, which is the same thing with honors algebra 2. Like honors algebra 2 versus my regular algebra 2 or even my pre-algebra 2 class. Like you guys get the harder problems when you're in honors algebra 2, the regular algebra 2, the pre-algebra 2. Plus the pacing is different in the pre-algebra 2. But anyway, so looking at number 39. Yes, keep it as a square root. No, don't change it to a decimal. It works nicely with the square root of 2. So using synthetic division, the first thing is to drop it down, so bring down the 1. And then Chelsea, what do? Right, which is okay so far. 1 times the square root of 2 is the square root of 2. And then you move diagonally up, and you place that number on top of the line. Then we need to add those together. And when you add them together, Chelsea, you leave it as
3 plus the square root.
Yeah, 3 plus the square root of 2. Like, that's how it looks. You actually can't add them together. You just leave it as 3 plus the square root of 2. And then you multiply again. So we are multiplying the square root of 2, and I'm going to write a little scratch work here, times 3 plus the square root of 2. Scratch work just kind of helps you see how to multiply them. You don't need to write it there, but it might give you a little bit of a visual. So Chelsea, the square root of 2 times 3.
Is 3 times the square root of 2.
So moving diagonal. And then the square root of 2 times the square root of 2 is just 2. And then you add vertically, and something really nice happens. Because you have -2 plus 3 square roots of 2 plus 2, and the 2's cancel because those are the like terms, so -2 plus 2 is 0. So we're just left with 3 square roots of 2. So the like term part cancels, we just have 3 square roots of 2. And then one more time, we're going to take the square root of 2 times 3 square roots of 2. Just writing it there for you to physically see what's happening with the problem. Really, there's a 1 in front here. There is no plus sign, so there should be no plus sign in my answer. When we multiply square roots, we multiply the numbers outside. Well, that's just 3. You multiply the numbers inside. That gives me the square root of 4. But Chelsea, really, that is just 6, because 3 times the square root of 4 is 3 times 2. And 3 times 2 makes 6. As I said, the answer was really nice. You don't have a square root in it. There is no decimal value for you to worry about. You do get a remainder, and that remainder is -8. If there's a remainder, that means what we divided by was not a factor, not a 0, not a solution, not an x-intercept. Any of those words are all the same concept. So this question, the directions, said to write your solution in the form, and this is how we've been writing it, x minus k, well, x minus the square root of 2, that's what we divided with, times the resulting polynomial or the resulting quotient. That's what our answer is. So, Brandon, that would be
X squared plus, and then in like parentheses or brackets, 3 plus the square root of 2, x plus 3 times the square root of 2.
good.
And then minus 8.
And then -8. Because it started with x cubed. So when we divide, we now have x squared. This all goes with x, and then we have our number. Questions? Anybody get that? Couple of you. Good. Okay, so let's look at 49, which was the last problem. 49, the directions said, use synthetic division to show that x is a solution. Use the results to factor the polynomial completely. So use synthetic division to show x is a solution, and it says x is equal to 1/2. So this one is a little bit of a fraction, but 1/2 is a pretty nice fraction. So working through exactly the same way. Alice, 2 times 1/2 is 1. Negative 15 plus 1 makes?
Negative
1/2 of negative 14 is?
14, negative 7,
And 27 minus 7, or plus negative 7 is?
20,
And then 1/2 of 20 is?
10.
Good. And then we get a remainder of 0. So we've used synthetic division to show that it's a factor or a solution because the remainder is 0. So that's a quick proof, algebraic. We've shown that it's a factor. You've proved it. You've verified it, whichever word you like the best. And then it wants us to factor it completely. Okay, so we've shown that 1/2 is a factor, so that's x minus 1/2. And then we have 2x squared minus 14x plus 20. So if we look back here, Michael, what's one thing we could do to factor that back part?
I took out the 2.
Yeah, let's take out a 2. And then,
I factored the x squared minus 7x plus 10 part. You can break that into x minus 5 and x minus 2.
questions so far? Okay, so there's one little thing left to do with this factoring problem. For something to be completely factored, when you look across, you should see just integers. And that first one has a fraction. We pulled out a GCF of 2. Equations are built so that one number, one factor, works with the other. So Brandon, what do you think you would do?
Distribute the 2 to the x minus 1.
Right, that 2 is pulled out of the one factor to help with the other factor. And like, they really are, like they work with each other, right? It kind of sounds weird. But like the equation knows to work with the factors that it has in it. So this is actually 2x minus 1, that GCF that we pulled out from the second factor. And then we have the x minus 5 and the x minus 2. But when you look at a factored problem, anytime we factored all throughout last year, you never had an x minus a 1/2 as a factor. It was always 2x minus 1, 3x plus 2, 5x minus 7, whatever the factors happen to be. So that GCF really does like help throughout the problem somewhere. And you'll see those coming up like in the next couple of sections. We'll actually do a problem like that again today. Questions? So this is considered completely factored. We could find the zeros by solving for each one of those parentheses. So a 0 at 1/2, a 0 at 5, a 0 at 2. That's what we're going to be going over today. Except today, it won't tell you that 1/2 is a 0. We're going to have to figure out how we can start the problem without knowing that number to start with. So that's the only difference from using the synthetic division. All these problems told you what to divide by. So today we're going to have to figure out that piece. What can we divide by? Questions? So in your notes, the last part of the section, really long section, 3 days. Like for us to spend 3 days on the section, there's a lot of stuff in it. So if you look at section 2.3, part 3, it should say the rational zero test. And hopefully, with the synthetic division, like you feel pretty comfortable with synthetic division. I said it should take you about 1 minute to do, but then Nina reminded me that it takes her a minute to write it down. So she was like, it's gonna take me 2 minutes. A minute to write the problem down and a minute to solve it. And I was like, all right, I'll give that to you. So, well, yeah, I mean, you do have to write the problem down. So I would say,
No, she writes so slow.
oh, she said that too.
She
She's
gets
like-
like this in the paper. She literally
She
writes
writes
on
neatly though.
Well, no, it's because
Yeah.
she can't see, but she doesn't like to wear glasses.
Mm.
top. She wears her fake ones.
Mm.
Instead
Yeah.
of her real ones.
So today we're going to talk about something called the rational zero test. This is a test that we can use, or a process, a mathematical process to use, to help us decide what the x-intercepts could be. So if you look at any problem, like here, we have 2x cubed minus x squared minus 13x plus 8. There are infinite x-intercepts that exist. This one has how many? At most 3. But there is, like, infinite numbers. So our goal is to decide, all right, if there's 3, how can I at least narrow it down to a smaller group to know which 3 that they could be? Because, I mean, I don't know, maybe it's 1, maybe it's 5, maybe it's 7, maybe it's negative 15, 2/3, 1/2, whatever numbers you want to come up with. Does that apply?
Yeah.
Okay. So the rational zero test is a way to help us kind of look at a problem, use numbers in the problem to at least break down and give us a small list and say, all right, these are the possible solutions. Can we decide which one of these solutions is actually an x-intercept? So the rational zero test has like 3 steps to it, but it's pretty short basic. The first step says to list all the factors of p, and in parentheses it says the constant term. A little refresher about the word rational. Rational means fraction. So any number that can be written as a fraction is considered a rational number. The square root of 2 is irrational because it's 1.41 and then blah, 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 blah. The decimal just goes on forever. So it is not an exact number, therefore it cannot be written as a fraction. So this gives us nice numbers to work with. Like fractions, I still consider to be a nice number. It's not the square root of 2. So we're going to look at possible rational zeros. So the constant term is p. That's always that end value that's by itself. P and Q are the variables we use to associate with rational functions. So those are just like variables are assigned for specific equations. M and B is for a line. A, B, C is for the quadratic formula, ax squared plus bx plus c. So P and Q go with rational functions, things that are fractions. So that's why that P is up here, it's not random. So what are the factors that make 8? Brandon?
1, 2, and 2 and 4. 1, 2, 4. 8.
There you go.
I knew I was forgetting something.
Yeah, okay. So 1 and 8, 2 and 4. Those 4 values are the factors of 4. However, Brandon, can you also have -1 times -8?
Yes.
Yeah. So we're going to put a plus or minus with that because you can have a +1 and a -8, or sorry, a -1 and a -8, or a +1 and a +8. Same thing with 2 and 4. So you'll always have plus or minus with those because you can have 2 positives to make positive, 2 negatives to make a positive value. And the same thing if that 8 was negative, because then I could have a positive and a negative. So we need to make sure we're accounting for all the possible factors. The Q value is called the leading coefficient. We know that number is always in front of the largest power. In this case, it's 2. Brandon, the only factors of 2 are
2 and 1.
2 and 1, 1 and 2. So by using those 2 numbers, that takes a list of infinite possibilities and shrinks it down to a list of possible zeros. And the way you find that list is by taking each p term and dividing it by your q values. I do it systematically, totally up to you how you want to do it. But I start with the first p value, which is 1, and I attach it to the 2 q values. So 1 divided by 1 is just 1. Instead of putting plus or minus, I just throw 1 plus or minus in front. And then 1 divided by 2 is really plus or minus a half. And then I move to the next p value and attach it to those same 2 q values. So 2 divided by 1 is really 2. 2 divided by 2 is 1, but it's already in the list. Don't write it again. We don't need a huge list. If it's already in the list, it's there. Now going to the 4. 4 divided by 1 is just 4. 4 divided by 2, already in my list, because 4 divided by 2 is 2. And then the last one, 8 divided by 1 is 8. 8 divided by 2 is 4, which is again in the list. So now I have 10. Of those 10, how many are x-intercepts? 3. So we went from an infinite number that we had no clue how to choose a value. Now at least we have 10. Now, this is going to make me sound slightly old. 22 years ago, when I was taking this class, I had a teacher named Mr. Swigert. I still remember his name, so I'm not that old. We did this all by hand because, and yes, there were calculators, there was technology, but we had a class that they were TI-81s, which are big, or chunkier. They still work, but we never used them. Unless it was calculus and an AP Calc, then I used them every once in a while when we absolutely needed them, which was like 10 times a year. So how do you know if a 0 is actually a 0, Brandon?
If you plug that value in for x and then it equals 0.
Yes, if you plug it in for x and it equals 0, or if you do quick synthetic division, which is what I had to do. Now don't write this down, but just kind of giving you an idea. You would start probably with 1 because it's the first number. That's the number I'm going to divide with, or as Brandon said, you could plug it in. And we have a 2, a -1, a -13, and an 8. As I said, synthetic division at this point hopefully takes you about a minute, plus a minute to write it down. So you bring down the 2, you multiply, you add, you multiply, you add, you multiply, you get a remainder. That might have been less than a minute, but I write fast, and I talk fast. Okay, so then, crap, remainder, that means 1 is not a solution. And then we move to the next one, which would be -1. We would do synthetic division a second time. If -1 was not an answer, darn, you move to 1/2, and you just hope that you find one of the zeros, one of those 3, sooner rather than getting to the 4. Sometimes it took up a whole page, sometimes you get lucky and like -1 is one of the answers. That's how we work through the problems. So, lucky for you, this is like meaningless, busy work. We're going to use the calculator to find one of them. But only one, because the rest, we're going to finish like we finished number 49. So number 49, they gave you a factor, or an x-intercept, or a 0, or a solution. We proved that it was 1, and then we factored the rest by hand. So that's what we're going to do. So we're still doing algebra, still doing pre-calc, but we're at least using the technology to help us. I mean, it would be a lot of fun, Brandon. You don't have to. I mean, you can go through and do it all by hand, just for fun. So that's what we're going to do with the second problem, and this is what I want you to do for your homework. So please, 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 don't just give me calculator answers, because at this point they mean nothing to me without some kind of algebraic support. So the rational 0 test is the support that proves to me that you've used your calculator, because from the calculator we're going to pick a number that's in the list. So the calculator will give you some answers. One of those has to be in this list, otherwise you can't use it. So if you get a number like 0.2357, you can't use it if it's not in the rational 0 list, because synthetic division will not work and give you a nice remainder of 0. So if you look at example 2 here, I think, if I can find it, just off a little bit with the calibration. There we go. List all the possible zeros. So that's the first step. This is how we can kind of then refer to the calculator and grab one from the list. So P, Q. We need the factors of P, the factors of Q, and then our nice big list of those possible values. Sometimes it's big, sometimes it's short. Just kind of depends. All of you wish you were alive 22 years ago so you could have done this by hand, right? And remember, if something simplifies and you already have it in your list, don't write it again. So you're taking P and dividing it by each of the Q values. So the first value of 1 goes to the 3 Q values. So 1 divided by 1, 1 divided by 2, 1 divided by 4. And then you're moving to the next number. If you prefer to put the plus or minus in front and parentheses around the whole group so you don't have to write plus or minus 15 times, that's fine. Just make sure you have the like parentheses around the whole group of numbers. So we have 1, a half, and a fourth. And then we would have 3 halves, 3 fourths. So that's what the P3. And then the p-value of 5 halves, 5 fourths. And then finally the p-value of 15. So if you keep it like kind of organized, you should have a nice list of numbers. Now here, there are 24 numbers up here. 3 of those 24 are the solutions. And again, I really would hope that it would be one of the first ones instead of one of the last ones. So with your calculator, after we have the list, in your calculator you're going to plug in that function, graph it, find a 0. Like we did last week, we found those zeros with the calculator. One of those zeros must be in this list so that we can use it in synthetic division to break it down, factor it out. If you find a 0 that's not in the list, that means it's a random decimal value that cannot be used with synthetic division. And there are 3 of them, so pick one of the ones that looks good to you. Pick a nice one. Is there a nice one? Maybe. Chelsea, what do you think? A -1. So this would be a problem that I'm going to be really excited about because the first one didn't work, but the -1 would be the second number I try, and yes, after 2 times, it works for you. So now we're going to show how it works, why it's a 0, just by verifying that it is. So it says use this 0, that's going to be the number we divide with, and synthetic division to factor this 0 out of the polynomial. So the whole goal is to take this big polynomial and break it down as far as we can go so that we can completely factor it. So we have the -1 from the calculator, we have a 4, -12, -1, +15. So tonight, have your phone out, set yourself 1 minute, see if you can do it in 1 minute or less. You can do like the mad minute test with the synthetic division.
The entire.
Just this part right here,
Oh.
just the synthetic division part. No, the whole problem, man, if you can do that in a minute, wow. I don't think I can even write that fast. So, break down the 4. Alice, -1 times 4 is 12, -12 and -4. Good.
That'd be 16, so then 15 and then
And 0. So you can even see, I bet you can do it less than that, I think. Depending how fast you can write. Okay, so boom, we proved that it was a 0. We got a 0 as a remainder, therefore it's a 0, it's an x-intercept, it's a factor, it's a solution. So part D, the last question says factor this polynomial completely. So we're going to take what we just found to be a factor by using synthetic division. Now that's x plus 1. And then we have the rest of it for x squared because it started as x cubed. We factored something out, so now it's x squared minus 16x plus 15. AC grouping. Everybody's favorite way to factor. Or at least Chelsea.
Yeah.
So Chelsea, 2 numbers that multiply to be 60 but add to be -16.
-6
Then we continue to factor. So we have those 2 factors. Pull out what they have in common. So they've got a 2x. And the second one has a -5. And then we end up with x plus 1. That's the one we found with the calculator. 2x minus 5, 2x minus 3. And if it wanted you to solve, you just say you have a -1, a 5 halves, and a 3 halves. And all of those are in the list above. So it's kind of like a little verification. But the list gives us at least like a shorter group of numbers, a smaller group of numbers to work with if we were doing it long problem. Some of it's pretty quick. Really, all of it we've talked about, besides the rational zero part. Questions? So let's see if we can look at a different type of problem. So if you flip it over. So the directions are the same. This one's just slightly different in the way the graph looks. So find the possible rational zeros. Use the calculator to find one rational zero from the list of them. These questions about any of the worksheets that I handed back the last 2 days, please come ask, see me, go over those. I tried to be as detailed as possible when I was grading them. I mean, besides like using the pair of numbers, like that's the way.
So even for the
Correct.
reason
Like you have to use the numbers at the top to give you initially like an education we have to set stuff initially.
find something that's always there.
You would try. It's gonna be awesome. Oh, shoot. Alright, so P is 1 and 2, Q is 1, 2, 3, and 6. And then we would have 1, 1/2, oops, I missed 1/3, 1/6. And then 2, 2 over 1, 2 over 3, and 2/6 is already there. So that should have been your list of possible zeros. So 12 of them, 12 options. When you look one up in the calculator, what number do you get, Chelsea?
2/3.
2/3. And you're like, oh snap, fractions. What a bummer. Fractions are your friends. We can divide with fractions, so we're going to divide with 2/3. It works out nicely, I promise, just like the square root of 2 one worked out nicely. So 6, -4, 3, -2. Bring down the 6. Chelsea, 2/3 times 6 is 4. -4 plus 4 is 0 times 2/3, no calculating this.
0.
And 3 plus 0 is,
3.
and then 2/3 times 3 is 2. Not so bad. It works out nicely. And the numbers are going to do that because it's supposed to be a factor. So my remainder has to be 0. So the numbers are going to work out nicely for you. So the last part says factor it completely. So we got that one factor as a fraction, x minus 2/3. And then the answer is what? How would we write that answer? The 6, 0, and 3. Michael?
6x squared plus 3.
Nice. So, factor it completely. What else can we do to factor this? take out a 3 from this back factor, which makes it what, Virginia?
2x squared plus 1.
And then the reason you're pulling out that 3 to help you finish factoring the rest of the problem is because it bumps into that first factor there with that fraction. So that makes it 3x minus 2, and then 2x squared plus 1. How many zeros did you find in your calculator, Michael?
1.
1. Why doesn't this last piece give us a 0, Virginia?
Because it doesn't work, but then you get a negative under the
Right. If you solved for this, you would take the 1 to the other side. You divide by 2, and you get x squared equals negative 1/2. If you take the square root of negative 1/2, it's imaginary. That's why there was only one option for you to choose from. So there's one real 0. That one real 0 is in our list. The other 2 aren't in the calculator because the calculator doesn't graph real and imaginary numbers. It doesn't work that way. That's why you only saw 1 in the calculator. Questions? So we have one last type of problem. So it's more like the problem's the same, it's just the answer kind of looks a little different. So the graph was different in this one because there was just one x-intercept in the graph to use. The other 2 are imaginary. So this last one is kind of similar. List all the zeros. Use the calculator to find the only, this should be find, the only rational 0. And then use synthetic division. So in your homework tonight, the directions just say to factor the polynomial. These are the steps that you need to be thinking about when you're factoring the polynomial. So you're using the rational 0 test, you're finding something in the calculator, and you're really using synthetic division. That's our method of factoring. Anybody tell me all the factors of 24? There's a bunch of them. Chelsea?
1, 2, 3, 4, 6, 8, 12, 24.
Yeah. The factors of Q are just plus or minus 1. So that means P divided by Q are just this list here. You're not going to have any fractions in the list because you're dividing by a value of 1.
Good afternoon. This is one quick announcement.
So in your
Cross-country
calculator,
practice is
if you
canceled
can
today.
find
Let me
one
repeat that.
rational
Cross-country
0.
is canceled today. Thank you.
So one rational 0. How many do you see in the calculator? Calculator show 3? So it should show you 3. One of them is rational and in the list. The other one should be like just decimal values. Chelsea? It is 3. So 3 is the only rational 0. The others, if you find them, they're still x-intercepts, but they're not a rational number that we can use. It's a huge decimal value, and we cannot use that with synthetic division because you'd have to round that number, and then you're never going to get a remainder of 0 once you round a number. So drop down the 1, multiply, add, multiply, add, multiply, add. Write it as a factor. And then you hope that what you have left is factorable, except in the problem it says use the quadratic formula to find the remaining zeros. If you don't have nice x-intercepts, like 2/3 or 1/2 or 3/4, your problem can't factor. Factoring gives you nice answers. Quadratic formula, completing the square, gives you those answers that have square roots. So the quadratic formula, everybody's friend, evil friend that comes to visit once a year and steals all your food, it's the quadratic formula. But it still works, still friends with it. Negative b plus or minus b squared minus 4 times a times c. Because this is not factorable, the only way to find the answer is to use the quadratic formula. I prefer using completing the square, just because this one has a lot of simplifying in it. Which is why I usually complete the square. Anybody know what number goes underneath the square root? Alice? 48. Okay, so there is a perfect square in 48. What times what makes 48? Perfect square. 4 and 12. Bigger than 4. There's a bigger one.
Uh, 16 and 4.
Yeah, 16 and 3. So negative 4 plus or minus 4 square roots of 3 divided by 2. Evil quadratic formula. And then reduce one more time. Divisible by 2 means we have negative 2 plus or minus 2 square root of 3. This number in your calculator is a decimal, let's see, negative 2 plus, this is almost square root 48, almost 7. So this will be like around 5-ish decimal value. But that's what it would look like if you're like giving an exact answer. So just to finish factoring it, making sure we answer the problem. So we have x minus 3. This becomes x plus 2 because you're adding the 2 to the other side. And then 1 has to be plus 2 square roots of 3. And then x plus 2 minus 2 square roots of 3. That's where the plus or minus part comes in. So it's both plus 2 because you add the 2 to the other side. And then we have that plus or minus. Because you're supposed to have it listed as factors, you should have it listed. Otherwise, you need to square the x plus 2 quantity. Question. So there's 6 problems in the book. 3 of those 6 problems are like this. And then there's 5 problems on the worksheet on page 29. Those 5 problems are a review of long division and synthetic division. You don't have to do the rational zero test for them. So just synthetic divide or use long division depending on what question's asking you for. Again, tomorrow we'll review, Monday we'll review,